Hello, this is Mrs. Hogan. In this video, I'm going to talk about the simple machine, pulleys. Some of the different simple machines are a lot alike, kind of like the wheel and axle was like a lever, I guess several levers put together and put onto an axle. Well, the pulley is a lot like the lever and the wheel and axle. Right? Because a pulley is a lever consisting of a wheel with a groove in its rim, which is used to change the direction and magnitude of a force exerted by a rope or cable. There are three different kinds of pulleys. The first two we're going to look at is the fixed pulley and the movable pulley. A fixed pulley is attached at the top and has a mechanical advantage of 1. A fixed pulley is like a first-class lever. The fulcrum right here is where the axle would be. Then on each side of the pulley would be your effort and your resistance. And you can tell that they would have the same distance from the fulcrum. If you turn the fixed pulley upside down, it would be a movable pulley. All right, so you've got one strand attached here, and then the other strand is where you're going to put your effort on, and this is where you would be pulling up. A movable pulley moves with the load and has a mechanical advantage of 2 because each rope is going to be supporting half of the resistance force. The movable pulley is like a second-class lever because here would be your fulcrum, then your resistance is going to be closest to the fulcrum, and your effort is farther away. You have a mechanical advantage with the movable pulley, and with the fixed pulley, you're getting a change of direction in your force to make it easier where you're pulling down instead of trying to pull up. You can find AMA and IMA for a pulley with the same formulas as the other simple machines. And you can also find the IMA by counting the number of strands. In a theoretical frictionless system, a pulley equalizes the tension in all the ropes supporting the weight. So the ideal mechanical advantage is going to be equal to the number of strands holding the resistance. This is only true if one continuous rope is used. So if you look at this picture here of the fixed pulley, notice there's only one strand actually supporting this resistance. So that's going to tell us then that our IMA is only going to be 1. Then if we look at this pulley system, notice here would be our resistance or our load, and it has 1, 2 strands supporting the weight. The rope here going over the fixed pulley is just changing direction, but it's not actually supporting this load. So we just count 1, 2, and that means our ideal mechanical advantage here is going to be 2. The third type of pulley we're going to look at is a fixed and a movable pulley combined together, and this is called a block and tackle. It is going to provide the mechanical advantage and a change of direction for your effort force. To find the IMA for this pulley system, we're going to count the number of strands supporting this weight. So we have 1, 2, 3, 4 supporting our weight here, our resistance force, and then this one here, just like before, is just changing the direction. It's not actually supporting the weight of our resistance. So our IMA for this system is going to be 4. To find then the actual amount of effort force, I can say my IMA and AMA would be equal. I'm going to assume that there's no friction on this. So I would say 4 equals my force resistance, which is 600 divided by x. When I solve for x, my force effort is going to be 150 pounds. If separate ropes or cables are used for the pulleys, you're going to treat this like a compound machine. In a compound machine, your IMA total is always going to be each IMAs multiplied together. So looking at this, I have one pulley system that's supporting 1, 2. So that's where they get this 2. Another pulley system, 1, 2, right here. And then a third one, again, 1, 2. So 2 times 2 times 2 equals 8. So the IMA for this particular pulley system is going to be 8. That's why the effort force up here is only 10 pounds. Or you can look at it and in your mind say 80, this one must hold 40, this one holds 40. Now this one holding 40 has 2 supporting it, so 20 and 20. And then right up above it, now we're just supporting 20, so half and half, 10 and 10. Either way that makes the most sense to you is the way you should do it. Your AMA is going to be found the same way as before with the other simple machines. So AMA equals force resistance over force effort. So what is the AMA of the pulley system on the right? Our resistance force is 800. Our effort force, it tells us, is 230 pounds. So 800 divided by 230, my pounds are going to cancel out, equals 3.48. Or 3.48 to 1 would be our ratio. Now, what is the efficiency of this pulley system here on the right? We counted the strands, 1, 2, 3, 4, that is supporting our resistance. So our IMA is going to be 4, and our AMA we just calculated as 3.48. So 3.48 divided by 4 times 100 is 87%. And we can assume that we were losing some of that force due to friction.